Hello, good morning to everyone here. I hope you are good. My name is Robinson Ramírez, and I will present the project entitled Experimental Validation of a Parabolic Solar Stove for Cooking Food, Desalination and Purification of Water in Colombia. This work presents the validation tests carried out on a solar stove in the city of Pereira, Colombia, for cooking and water treatment processes, which has a concentration factor of 3 sols, a volumetric capacity of 3 liters, a diameter of the paraboloid of 1.28 meters, and a height of 1.1 meters. Going into context, in Colombia, cultural acceptance and infrastructure are the great barriers that renewable energies have for their implementation in areas of the country that do not have access to essential public services. For this reason, the fuel used for cooking food is largely firewood, which generates environmental pollution, felling of trees, and respiratory diseases. However, at present, the United Nations organization proposed 17 Sustainable Development Objectives, of which 3 are directly linked to this project. What are they? Affordable and clean energy, climate action, and life on land. Their purpose is to reduce the burning of wood as fuel, and thus mitigate the generated environmental impact and the consequent diseases. To calculate the thermal performance of the solar stove, the ACS 580 standard and the BIS standard were used. However, the definition of the first law of thermodynamics is the one normally used for the calculation of thermal performance. In this particular case, the 3 mathematical models were used to calculate power and thermal efficiency and make a comparison between the results obtained. For the experimental methodology in the first instance, a bibliographic review was made to establish a methodology according to the research, to later execute the different tests and the measurement of the established parameters. After obtaining the data, both qualitative and quantitative, these results are interpreted and selected according to the established methodology. In order to determine the thermal performance of the stove and obtain the conclusions of the investigation, the choice of materials for the construction of the solar stove was made with 2 purposes. The first was to provide better stability to the structure, and the second to take advantage of the greater amount of solar radiation. So, a moderately selective paint was used to cover the pot, and a reflective film to cover the paraboloid. Likewise, for data collection, a thermographic camera was used to determine the surface temperature of the pot, a digital thermometer to measure the temperature of the working fluid, and a pyranometer to determine solar radiation. In this video, taken with the thermographic camera, you can see the progressive increase in temperature on the surface of the pot during one of the cooking tests with 2 liters of water carried out at 11 in the morning under an average solar radiation of 807.3 watts per square meters. Now, to make the data obtained in the different experimental tests repeatable, the following step-by-step was established to execute them. Temperatures are first taken at the start of each test, followed by placing the solar stove fully exposed to the sun. Subsequently, the pot is filled with water or oil, as the case may be, and placed on the grill. Afterwards, temperatures and solar radiation are still taken in 5-minute intervals, and the time it takes for the food to cook. Finally, the data obtained is analyzed after executing the different cooking tests. This graph was obtained showing the behavior of solar radiation, the temperature of the surface of the pot, the temperature of the fluid, and the temperature of the environment during a heating test with water, where the maximum temperature reached is 96 degrees Celsius. Additionally, the period of the day where the best conditions of solar radiation and temperature increase occur is between 10 a.m. and 4 p.m. In Figure 9 and Figure 10, we have the thermal power and efficiency of the solar stove, respectively, calculated with the proposed mathematical models and obtaining power values between 0.6 and 0.4 kilowatts, and instantaneous thermal efficiencies between 42 and 3%. Likewise, a small menu was made where you have the temperature, and cooking time of some foods. In this case we have plantain, eggs, spaghetti, potatoes, stew, and beef. On the other hand, there is a water purification and desalination component, which consists of an evaporation, condensation, and filtration system adapted to the solar stove, and whose purpose is to improve the quality of the water and make it suitable for human consumption. From there, these two graphs are obtained, where the results of the purification and desalination of water are shown for 4 specific parameters that indicate the quality of the water, which are the degree of turbidity, total solids, total coliforms, and Escherichia coli present in the water. In this case, a considerable reduction of said parameters was obtained after the process in the solar stove, and obtaining that the treated water complies with the drinking water standards. Now, one of the most relevant aspects for this type of research beyond the theoretical and experimental component is the socio-environmental impact that is generated due to the implementation of these technologies. In the social sector, we have to reduce greenhouse gas emission levels, ensuring a better quality of life for the user, reducing diseases caused by inhalation of carbon dioxide, while reducing the consumption of firewood, which this linked to deforestation. In the economic, we have that the savings generated by not consuming gas, due to the use of 6 hours a day of the stove, is approximately $6.5 per month, allowing to recover the initial investment of the purchase of the stove in approximately 24 months of use and generating gas savings for more than 8 years. Finally, in the environmental area, due to the use of the solar stove, 375.22 kilograms of carbon dioxide is being emitted per year, contributing to the sustainable development of the region. After the investigation, the following conclusions were reached. The maximum temperatures reached during the different cooking tests were 96 degrees Celsius with water and 132 degrees Celsius with oil, which allows the cooking of a large number of foods in approximately 20 to 40 minutes. It was also concluded that the solar stove can be used to purify water from different streams or desalinate seawater, since the water obtained complies with the parameters of Colombian regulations for human consumption. Finally, it was concluded that the solar stove can be used for the proposed applications in tropical climates or in climates with longer hours of solar and solar radiation. This is the bibliography, where the underlined articles were the most relevant for this investigation. Thank you very much for your attention. Here is my email in case you have any questions or want to contact me.